Well, welcome, Goran Milovanovic, lead data scientist at Smart Talk to an owner at Data Collective, who will speak on deciphering the AI landscape, business market trends, and emerging risks. Goran will present a comprehensive study on the state of AI in business, analyzing market dynamics, risks, and the direction of the AI market using natural language processing and leading language models. His talk aims to enhance our understanding of the AI business and explore the uncharted territories we may face in the future. Goran, please.
Hi, thank you. Thank you, Zachan. Hi, everyone. Okay, so I caught a cold, so I guess reading will be beneficial this time. Only this time, I promise. So this is, I guess, the thingy. The thingy works. Strange, right? Okay, thank you. So I'll begin by this reflecting on really everything that has happened in the past year, a year in which actually the history of the IT industry changed. I thought it would be beneficial for all of us if I attempt to provide an overview and analysis, high-level analysis, I would say, what generative AI has achieved, what it hasn't yet achieved, what are the relevant conclusions for the existing and the emerging business models that rely on their use, and that will be a part of the focus of my talk. I will start by an overview of what happened in terms of scientific and technological breakthroughs, but I want to lead us towards the understanding of the business models. How do we want to actually produce value for our economies by these technologies? So I've been wholly professionally devoted this year to developing technologies in media analytics that are based on large language models and generative AIs, and that can seriously shift the boundaries of what is possible in media and editorial analytics. On the other hand, I've also invested a lot into personal experiments with these technologies, exploring various use cases that simply seemed interesting to me. So I thought it would be best if I share with you what I think about all of this today, after all that research and the prototypes that I built, dilemmas, successes, and partial successes. So let's start by discussing the nature of the changes that we are witnessing, yes, on the nature of the revolution. So, you know, I will begin by discussion a little bit of natural intelligence. We must start by thinking about natural intelligence because human natural intelligence represents the golden standard for the field of artificial intelligence. That is what we want to achieve in the end, right? In my opinion, in the current revolution of generative AI, we have managed to achieve some incredible success in simulating certain functions of the natural intelligence, while some crucial things that our mind does, we have not yet been able to decipher computationally. And then let's see where we are at the moment. In cognitive psychology, precisely in computational cognitive psychology, a discipline in which I spent 2 decades in the study and academic career, we now distinguish two different ways in which the human mind forms thoughts, right? So these are referred to as System 1 and System 2 thinking, most often in the literature. And thinking in System 1 is something which is fast, associative, automatic, stereotypical. We frequently use it every day, and it's almost unconscious. That's our automatic, implicit, and approximate, and also highly efficient mode of thinking or reasoning, if you like. On the other hand, we have the so-called System 2 thinking. I will explain a little bit more about these 2 modes of reasoning later. And that mode is slow, it requires deliberate conscious effort, it relies on laws of logic in reasoning, and it is used less frequently than the System 1. That's our explicit, analytical, and rule-based system of thinking. So let me show you some examples that might help us illustrate. So, you know, if we are in the context of a hospital or healthcare system or anything in relation to medical services, and we need to formulate some sentences, something related to that context in speech or in our thinking, the words that might come up to mind are, for example, hospital, and then the word nurse might appear, right, nurse, and then, of course, doctor. So word by word, generated associatively in an associative manner, following only how certain concepts are often connected in a given context, how often they simply go together in a context. So this ability of the human mind to easily generate appropriate elements of the discourse will set the foundation for something that we need to think about or say, and say in another context, of, for example, university philosophy, the word doctor might easily be recalled again. And that's something that your brain automatically does for you, this recall of associative relations. That is easy It's a nice flow and happens almost unconsciously. You even cannot control all these things all the time. So, of course, the word doctor will have a somewhat different meaning than in the first context, but it absolutely fits the second one as well. So evoking associated words from memory is something that our mind does with incredible ease. It's based on our previous experience, and we know that it is guided by processes of associative statistical learning in our neural system. Now, system 2 is, okay, so yeah, for the system 1, we can characterize that as the associative machinery of your mind. So it's associative reasoning and our associative memory. Human beings have many forms of memories, by the way. There is something completely different in the associative memory, which is called the semantic memory. It was for decades the topic of my study in cognitive science. Now, thinking or reasoning in the so-called system 2 is based on something which is called formal semantics. And this may already sound complicated, but it's actually something without which we wouldn't even be human beings, nor would we be able to do many of the things that we do every day. And let's take a look at what actually this entails, right? Look. So, system 2 of thinking, the one which is based on formal semantics, it rests on something which we call, and that was, we can call it, but it was also called, obviously, in the history of philosophy and psychology before, like that, so the language of thought, we say. It's based on strict abstract rules that govern different domains which we can think, such as the verbal or visual domain, for example. These rules govern the ways in which concepts whose meanings we understand can be combined into more complex wholes. I will be giving examples, based on which we precisely understand the structure of information of a situation or the problem that we need to solve at hand. This abstract grammar, which actually represents the true logical machinery of our reasoning, organizing relationships among concepts rather than words, is the formal semantics on which system 2 thinking is based. Let's take a look at more examples. Look now, for example, a significant example of system 2 thinking is undoubtedly the understanding of geometric relations, right? So the visual grammar of the world and even the understanding of intuitive physics. The understanding of intuitive physics means the ability of human mind that, for example, is able to predict the trajectories of objects around us upon their entering different interactions, right? So you don't do that. The real human mind, our human mind, doesn't predict the physical motion by explicitly calculating the equations of Newtonian mechanics, right? We do it in an intuitive way, but in that intuitive way, we still do understand the laws and regularities that govern the domain of physics, right? So understanding relations such as above, below, beside, across, and others, and reasoning about the relationships among objects that enter into these relations, those are all examples of what system 2 thinking does. Contemporary generative AI systems are particularly poor at this. I will be providing examples, producing errors when explicitly forced to engage in such type of reasoning. And this is no surprise, because we already know that they were actually based on neural networks that are governed by laws of associative learning that are more characteristic of system 1. Also, understanding agency and causality, which in the social domain maps onto what we call folk psychology in cognitive psychology, understanding agency and causality in social relations, for example, right, are also within the capacity of system 2 thinking. So understanding that a person in a picture will lose their life if they behave in the depicted manner is not something we understand because people frequently do it. So people do not frequently step into an open abyss, fall and die, right? So it's not something that you can easily learn in an associative manner, simply because that's not something which is frequently observed in the discourse or in the reality at all, right? So we understand that something bad will happen here because we intuitively know, we understand physics intuitively. We comprehend that the transformations of a human body will undergo if it enters free fall from a great height through Earth's gravitational field, and we understand the consequences that that will have. Understanding that a person that does this will eventually die by falling in the abyss is formally the same as understanding what will happen to a car if it falls under the abyss. So both are both are governed by the same set of laws. And that intuitive understanding is enough to understand that an object of this class, human body, will cause this human to die and cause a car to crash, right? So, you know, even when we don't use scientific terms explicitly, the scientists within us, that system 2, which is based on strict and abstract rules that reveal how the properties of certain concepts influence their interaction, and how, for that reason, some interactions in the world must take a regular structure and result in predictable consequences, and that is actually those predictions that the system 2 does for you and me. Now, there is a rather important assumption of this system 2 reasoning, and that's something which is called compositionality. It might be the case that you have already heard about this in discussions regarding generative AI systems and AI in general, and it's simpler than you might think, right? So probably this slide is not promising that it's too simple, but trust me, it's really simple. Compositionality means nothing more than the idea that the meaning of combining certain concepts together is a function of the meaning of the concepts that enter the combination. Okay, simply put, well, what the two things are before our mind attempts to create the third thing by combining them, okay, what these concepts are in the beginning will determine exactly what that third new thing will mean and what properties it will have. Examples. A dog psychiatrist. Is this a dog who is a psychiatrist, or is this a psychiatrist for dogs? And of course it's a psychiatrist for dogs, right? Okay. But how often do the words, or concepts if you like, of a dog and a psychiatrist appear together in all imaginable context of the textual discourse on the planet that you use to train large language models nowadays? Is that something that you can use, that you can actually learn by associating text, by encoding the context in the transformers architecture, feed-forward networks, and then doing massive backprop across that thing? Is that possible? Let me give you maybe a more actual example. A prompt engineer. Up until a year ago, the profession of prompt engineer wasn't even mentioned. Today, everyone knows what a prompt engineer. Plenty of people would like to learn a little bit more about it here. So, however, the meaning of this term couldn't have been formed as rapidly as it was about a year ago if it wasn't based on a prior understanding of what prompt is and who an engineer is. Okay, now we can be a bit more lenient in our assessment here. An associative system, so something similar to ChatGPT, Anthropic's Claude, and other large language models. An associative system could produce such a composite of words based on the fact that there are many things that are similar to what a prompt is, and many things that are similar to what an engineer is, which have been previously combined, and then these combinations were recorded in the text. And then it can recall that associative knowledge and figure out that combining prompt and engineer is something which actually makes sense. It produces a coherent context, a coherent discourse. That would be true, right? Also, you could guess that prompt engineering is likely a profession, as many professional titles in the IT industry actually end up with the word engineer, right? But this is certainly not the way the human mind rapidly creates and understands the meanings of these concepts. So look, the problems in generative AI stemming from the fact that they actually lack the system tool of reasoning, right? These problems are easier to illustrate in the visual domain than in the textual domain. For various reasons, the visual domain is easier for this illustration. Here I have the results of two prompts that were sent to the latest update of the OpenAI DALL-E 3 system. So the prompt for the upper pair of images was a horse riding another horse, okay? While the prompt, careful now, the prompt for this lower pair of images was the famous example, a unicorn riding an astronaut. What happens here? Look, in associative thinking, in system 1 thinking, the places of concepts that are entering a similarity relation are interchangeable. That's completely symmetric, okay? So, I don't know, this object here is similar to this object here up to some degree, right? Okay, and it's vice versa. The similarity is a symmetrical relation, right? So there's nothing about the placeholders that is special there, right? The system faced with the task of placing one horse on another, that's the reason why it manages to solve that problem. It's not bad after all, right? Now look, what happened with the unicorn riding an astronaut example? Where actually I got two results from DALL-E 3, and in both of them, of course, the astronaut is riding a unicorn, okay? What happened there? Well, the thing is, since unicorns do not ride anyone or anything that often, nor the astronauts are something that you ride, the system encounters difficulties when it needs to apply the meaning of the relation riding to the two concepts whose meaning now it has to somehow modify in order to make them enter that relationship. That can do only system 2. System 1 is not sensitive to such things, right? It can fake it a little bit. It can fake it up to a degree, right? But fundamentally, it operates in a completely different way, right? So, you know, children and adults might find the request to draw something like this strange, but human creativity will not have a problem in solving these things at all, you know? Even a child will figure out a way. It will be an ugly drawing. It will be an unusual drawing, but, you know, children will draw you a unicorn riding an astronaut. I can do it. You can do it. Anyone can do it. And I don't need to repeat that prompt to you 500 times. You will understand what it does the first one shot, right? And that is what system 2, the formal semantic system, does. That is, it enables such creative compositions of concepts. Now, all these things that characterize the modern generative AIs, they have consequences, right? So the first one is no compositionality, hallucinations stay. Full stop. This is Mid-Journey, several months ago. I really liked it. It looks like a beautiful drawing that a surrealist painter might wish to draw, but I asked for an anatomical drawing of a human hand with the palm facing the viewer, okay? I got the nails on the wrong side. Why? Because it absolutely has no idea about the visual grammar, the geoms, as we say, that compose the human hand. It does not understand where the nails should be placed, right? That's the reason. It doesn't understand the grammar of the visual world. It works in a purely associative manner, unlike our brain. So that is one thing. There is a more general consequence, and I would really like to stress this thing. You know, no system 2 reasoning, and without compositionality, you will not get the system 2 reasoning to work. No system 2 reasoning, no artificial general intelligence. I'm sad to say, just face it, right? I think this is very important to say. In a cacophony of statements in media and social media and elsewhere, the discussions of when will OpenAI / Anthropic / some third startup finally hit the artificial general intelligence, hitting technological singularity, solving all the problems, let me tell you, they are nowhere near. We are nowhere near getting there. So, yeah, I understand the euphoria. I partly support the euphoria. I really enjoy all the recent technological developments that has happened here. But this thing, the real AGI, the real thing, the superintelligence, that's the next revolution. It's still not planned. You are not getting it in the following 5, 10, 15 years, most probably. It's actually very difficult to get there. But let's be fair, and let's see how can we characterize the nature of what was happening in the previous 10 years, which actually culminated in this previous year. So I think it's fair to say that we have already developed a form of superintelligence, and I will call it a system 1 superintelligence. Why? Large language models coordinate such an amount of associative mass from the text that they learn statistically from, so that the human mind of any individual cannot really compete with them, okay? So I believe it's realistic to claim this. If we are talking about associative system 1 thinking, we have probably already created an artificial system based on principles that are similar to those used by biological brains, and that the system, pragmatically speaking, is already stronger than us when we measure only on associative functions. So I would say one form of superintelligence we already have, but that's a constrained form. That is the system 1 form of superintelligence. At the same time, AGI, no, sorry. We'll do it later, at some point, I promise. And everything said here is not to say that achieving system 1 superintelligence is not super useful. To the contrary, we learned in the previous year what can be done with these generative AI systems, and you know what? I mean, it's amazing, at least I think. So let's begin by reviewing the consequences of these facts that characterize the state of affairs in the development of the AI technologies. Let's try thinking about business models. Let's try thinking about how do we put what we have to production, as you say, in software engineering, which means how do we actually get to produce value from these things. There are two dominant business models that emerged in the previous years. One of them, rather new, happened last year. I want to make a comparison between them, and I want to measure the odds of being successful if you play one game or the other game, okay? The fact that you really need to control these large language models when you use them. The fact that you need to do something to prevent hallucinations, direct them into discourse, enhance them, to provide advanced reasoning in some domain, even looking for system 2-like results, knowing that they fundamentally cannot do it. All these facts, they imply the existence of the very fundamental business model that we are playing these days, right? So we have a client and we need to deliver something, right? Through prompt engineering and having a large language model somewhere in the backend. And then what do we do? So we surround the model by tons of external sources. Okay, we equip the model with internet search capabilities in order to refresh the information, because it will not be trained every now and then, because training processes are extremely expensive and long-lasting. So we can add any other external sources that we need. We will use knowledge databases because they are very nicely suited in this situation. You can use semantic search against these databases based on the similarity to your prompt or only the parts of the prompt. You can also add semantic knowledge from knowledge graphs. Of course, you will also need to perform some embedding there in order to figure out what is relevant. And that is how you surround the large language model and provide more support to it to make it work for you and avoid making associative errors, which are, by the way, erroneously called hallucinations. In psychology, we would never say that that is a hallucination. It was a software engineer who used that term in the context. Hallucinations in psychology are something else, just a note, a side note. But never mind. So, look, essentially, this is one model. There are two businesses that I want to talk about here, okay? Both of them referring to the previous discussion in different ways. One is something that I will call AI as a service. And by AI as a service, I mean the actual building and training of large language models, the big thing. The other I will call DevSAI, and by this I mean a business model that creates additional value by specializing large language models, controlling their operation with external sources, as shown here in the previous slide. So let's talk about this thing. So what is the value proposition here for the AI as a service business? Well, obviously, there is a simple answer. The value proposition here is nothing else but scale. Why? Everything we get from the providers of large language systems, large language model systems, is based on scale, because they can invest in extremely high cost of an infrastructure. They can invest into extremely long-lasting and very expensive training processes. The collection of data sets and the preparation of data, that's a story for itself. And of course, there is a very important, from business perspective, very important thing, which is called the inference cost, okay? And they can really bear, especially the big tech, they can bear with all this cost. So actually, the proposition here can be formulated easily. It's scale. That is what they sell, right? And that is how, by providing services, they offer added value. We have to pay for that. What's the proposition here? In the DevSAI approach, it's called specialization, right? The infrastructural cost of this business model exists, but they're far, far cheaper than the respective costs in the AI business. I can now hear people from, medium-sized enterprises, startups, scaling, saying, "Are you crazy? The infrastructural costs are low." Speaking relatively, just comparing with the cost of the AI as a service business, they are really low, okay? So compute costs, of course, which if you're running cloud, then you are, aren't you? They go together with infra costs, of course, in this case, if you're on a cloud service. And there is a specific cost in this business, which is called the knowledge engineering cost. And that is because you really have to be very careful in the design of all these systems surrounding the large language model to put all the expertise that you will be using in domain-specific tasks, to put all the knowledge that you have, additional instructions, how you will design them, how you will do similarity search. Depending on the domain, depending on the complexity of what you're doing, that might be quite, it could be quite time-consuming and expensive, but really not that expensive as an assembling a data set to train a large language model. So let's talk strategies here. So look, let's for a moment assume that you and I will not be developing something as large as GPT-4 or Anthropic's Claude or Amazon's Titan or something similar to it, okay? Is it a good business strategy to start developing domain-specific, specialized large language models in-house. Is that a good business strategy? Look, given the infrastructural costs, given the data costs, training costs, inference costs, given the fact that you will have to retrain every now and then, I don't think so. I don't think so. Let me give you an example. This was big in news several months ago. Most of you remember this, the Bloomberg GPT thing. Sorry, the Bloomberg GPT thing, okay? So the Bloomberg GPT was, or is, a specialized domain-specific large language model in the domain of financial discourse, okay? It was trained on the AWS SageMaker system. It has only 50 billion parameters. I say only because in comparison only to GPT, which was a predecessor to ChatGPT, ChatGPT ran on 175 billion parameters in order to learn and mimic the structure of the natural language. So this is by means of, today's standards, this is a small model. So that thing was trained for 53 days and the cost estimate is between $1 million, $2.7 million, okay? Now, I'm not sure how much Bloomberg is saying about what they're doing this thing. Is it running in production? Is it running inferences? Do they sell reasoning from this model? I know that they tested it against at the sentiment analysis tasks. It performed perfectly, of course, okay? But if the whole thing was built to do sentiment analysis, listen, I mean, $1 million investment, 2.7 million eventually. Does that make sense? Someone with, I have to say, remarkable expertise in this area told me several weeks after this happened that it's a brilliant marketing move. Well, maybe Bloomberg can invest this money in marketing. I cannot. I don't know about you. Anyways, I'm not sure where is the return on investment if you really direct your business into this direction. On the other hand, look, if you take this step, right, and take the devs AI strategy where you actually pay money to use someone else's generative AI in the background, and then, I don't know, pick your favorite model. I like both GPT-4, but I can tell you Claude 2 Anthropics is also a beast. And you decide to specialize by actually doing knowledge engineering and surrounding the model with all these services in what is complicated. It's called retrieval augmented framework. It was actually popularized in a paper published by Meta in, I think, 2022 or something. Then it seems that your costs, thanks to this knowledge engineering, are way, way, way lower than anything that you would need to invest in order to specialize the model. And there is another thing. You might end up being more efficient by doing this thing. Why? Well, simply, once, as I told you, once when you have a domain-specific large language model, you will need to retrain that thing every now and then. You need to add new information. Training, that's a very high cost, right? So having a model and training a model is one thing. Maintaining a model plus inference costs and selling that for money, that's completely, totally different league of business, So as a domain-specific player in the market, do you want to go there? I'm not sure. So how I see after this 1 year of craze about generative AI and all these new things that happened, training a general purpose LLM is okay, definitely. If you are in this league, if you're there, then it's definitely okay. But if you go for domain-specific LLMs and start specializing these models, the devs AI paradigm might beat you, and most probably, I would predict that it would. So what are the current trends here? Let's see, what are the market trends? What can we observe after this only 12 months of observation? What's happening? Well, you know what? There are not too many domain-specific large language models. Many were trained. I'm sure that there are a dozen more. Okay, I'm sure that on Hugging Face you will find tons of things, but I wonder how many of them are really doing something and how many of them are simply, parts of someone's research, which I really want only to encourage, okay? But speaking from a business perspective, I'm not sure that this is a way to go. MedPalm 2 is actually Google's. I'm not sure about the destiny of Bloomberg GPT. Some of them, these things are for banks like KGPT, etc. On the other hand, let's see how the big tech providers of generative AI let's see what they were doing recently and try to decipher where their business, where they want to target, where they want to go from their steps, from their moves. Look, like 2 weeks ago, Sam Altman's on Dev Day, OpenAI, introduced GPT-4 Turbo with 128K tokens context, okay? If you don't understand these technicalities, I will show you that it's really not important. Developers will understand, and they want the developers to understand, that's the thing. So JSON response format, which you can now enforce. Then reproducible outputs, what's that? Stateful API conversation memory, very important again for developers because it's ChatGPT user or ChatGPT Plus user, you already had that, even if you didn't know that you have it. At the same time, not at the same time, 2 or 3 days ago only, Anthropic introduced Claude 2.0, which has almost all of the functionality of the GPT models, has a 200K token context window and search capabilities already in place to build applications in the retrieval augmented framework. Now look, if you are a business person who is maybe not following all the technical details, I happen to live in both worlds. You know, half of me is coding, half of me is thinking about where the market is going. And you don't get all these details, or you're just a ChatGPT Plus user enjoying the application. It's really helpful. I use it every day. You know, you might not understand all these things, and it's not important. And you know why it's not important? Because the recent moves of the big tech in this game are not targeting you at all. OpenAI is not interested in ChatGPT Plus as its primary product. They are targeting the devs AI business. That is where they want to go. They want to sell compute, and they're doing everything to make the developer's life easier in that respect. They also figured out smaller players will be specializing. Let's make their life easier. OpenAI does that. Anthropic obviously is doing that too, to mention just these 2 big players. So I would say that we are entering 2024 with only one clearly recognizable business risk, and that is actually can be expressed as the likelihood of the match between these 2 things. Nothing more than that. So in comparison to AI as a service, they have high infrastructural costs. In comparison to them, we have low. Doesn't have to mean that relatively for your business they are low. But you know, I mean, you don't have to run the 3rd and the 5th most powerful supercomputer in the world to run your business, don't you? Yeah. They have high costs of training. We don't even have in the DevCI side something which is comparable to that. Well, you can say, well, you know, I can fine-tune models. Well, you can, okay, but again, that training is not going to cost a small fraction of what they will have to invest in retraining their models, right? Also, data there, they have a really high cost, especially now when media started blocking access to their spiders. Okay, so everyone actually is feeling that data is now really becoming gold. They want to make money out of them. Here on the DevCI side, it's your knowledge engineering, but it can be only estimated as a moderate, let's say, cost, if not, again, low cost in comparison to what they are doing. So, of course, they are facing high costs of inference. That's the reason why players like OpenAI are struggling to provide service across all the hundreds of millions of users. We have experienced a huge outage only the day before yesterday, I think. And I understand why is that happening. It's really not easy to maintain all that load. On the other side, our compute costs, because we will be buying that through their infrastructure. So inference is a kind of inference cost with them is something analog to what compute cost is with us, taken together with the infrastructural costs, right? We probably have high costs there, and that red question mark is the risk. So this is the business equation beyond the beautiful equations of the transformers architecture and the backprop and all other things, the tricks that are happening there and running these beautiful machines for us now. This business equation is going to be the focus of balancing out in 2024, because at the end of the talk, I want to remind you of one thing. You know, something really remarkable happened in the previous year, but only this year, only in 2023, we will be able to live out of glory that generative AI was actually developed. Next year, Next year, AI-powered services and applications are, business as usual. Everyone has them on their phone, their Microsoft Word, anywhere else. So in the next year, it will be all about balancing out this business equation and seeing how to make real value out of it. So thank you. Thank you very much.
Let's see about the questions. I have one, because I think you're the first on this stage who said that we should not even think about AGI in the next, I'll say 15 years. That was your prediction.
It's going to be 15, but...
because everybody was saying, maybe not next year, but year after the next.
That is not happening.
Why?
It's not happening because the philosophy, the large language models, the principles upon which machines are trained now, this associative machinery that we are using, that will not in principle ever develop into a real formal system that any digital computers is actually running when you program in Python or run Microsoft Windows, right? It cannot be done, or at least until now, after a ton of mathematical studies, we didn't figure out how is that possible at all, right? You need to
you
implement
don't think there's a
real
possibility
machinery.
that there's a breakthrough in some
Not
other
in
way?
that sense. No, in particular, this is a domain where quantity will never become quality. And that's the problem. So just growing a larger model will not lead you there. That's the thing. So we need new, fresh technological breakthroughs. We need to understand how to put together the successes from the fields in the so-called symbolic AI, which is a totally different game than the large language models. We need a synthesis of these two approaches in order to start making something which really looks like natural human intelligence. At that point, when I see technological breakthroughs there, I would start worrying about superintelligence at that point, but not before that.
What about businesses? Because this was a great breakthrough, and now probably we would look for another decade to make money out of this, because if we get another technology too quick, I mean, we won't be even using this. And this seems to be quite interesting.
I wouldn't like to enter such discussions on what business strategies and what big businesses that can develop these technologies will do, They will do what they think is best to do. What I know is that the research on artificial intelligence will simply not stop. So it might not happen in the business arena. Now it's interesting times, because now we live the times where the most important developments do not happen in academia anymore. On the other hand, they can happen in big tech companies. But you know what? If they don't do it, something will happen in academia. We will know about it. The first who buys will be the next billionaire. So it's unstoppable, really, if it can be done. And we are trying since 1950s. Neural networks were not invented yesterday. Symbolic AI was started in the late 50s with the ideas of automated machine translations and Chomsky's works, etc. So we have the ingredients. We don't know how to combine.
But as you mentioned, I mean, you cannot compete with the big companies, because
not really. You don't have
working on AI or generative AI needs a lot of money, because you need huge investments to train your systems. Yeah. So it's limited to who can be doing this.
At this point...
I mean, I'm asking because you mentioned academia. I'm not sure that they have that money.
It's questionable. They can find it probably. But at this point, yes, it's very, very difficult to compete with a competitor who is actually able to invest in the whole infrastructure and the training process that you need to build these kinds of things. Look, there was a recent analysis a few months or a few weeks ago by, I'm not sure if that was The Economist, perhaps, okay, but you have only 2 countries in the world playing in this arena now. You have only 2 countries in the world, the United States and China. If you want to plot the investment or even the amount of significant publications on AI from the countries of European Union, you need a logarithmic scale here in order just to be able to see the charts. They are nowhere there. So doing these kinds of things at this point, this is really very exclusive. So Baidu can do it, and American companies can do it.
Before I give the question to, I have just one remark. So who is capable to make, design, and produce a mobile phone can be doing something on AI? Because that's China, United States, and Korea, of course. We haven't seen Korea in artificial intelligence. I wouldn't be surprised. But European Union is not producing any mobile phones.
Unfortunately, I don't know. Yeah, that's an interesting insight. That there is a parallel between that. but in European Union, we're very, very, very late in the AI arena. I mean, they're so late that I don't think they will be ever able to catch up at this point.
Question.
Please.
Yeah, first of all, thank you for the lecture. It was really nice, this overview of what happened in the last year and pretty much a revolution that we all witnessed. And I wondered when you were talking, what are your thoughts, what's your take on when the LLM happened as it happened over the last year, let's say, so dramatically? Did you expect such, I would say, dramatic, sophistication of the product that we got since ChatGPT was out in the air? Because, of course, you were talking about different systems of thinking and how even with this level of sophistication, we are nowhere near to the human level of, let's say, cognition or intelligence or whatever we call it. But was it really like this scaling thing and what it led to with ChatGPT and other things? Was it kind of surprise to you or not?
Not kind of surprised. I was fascinated by it. I was never expecting it. If you listen, I'm programming computers since the 80s, since 1993, which is 30 years ago. I started doing academic fundamental research in cognitive sciences. If you ask me that a year ago, when we already knew what transformer architectures can do with language, right? If you ask me a year ago, will you have a natural language interface like ChatGPT has in November 2022, I would tell you you're out of your mind, that we'll have to wait for 10 or 15 years more. Interestingly, Geoffrey Hinton, Turing Award winner who left Google, by the way, expressed the same or similar sentiment in an interview several months ago. Geoffrey Hinton,
father of AI,
Geoffrey Hinton said that, you know, it's all too fast. It's all too fast. We didn't expect this thing and all the fuss that it actually created. Very interesting, and what I learned only recently from a very, I would say, good article in The Atlantic. So OpenAI, they were very surprised by the success of ChatGPT themselves. The 30th November release of the ChatGPT free interface was perceived as a low-key research release in ChatGPT. They even printed stickers for their laptops after that, wearing T-shirts with like a low-key research release that accrued 100 million users in the first week. So everyone seemed to be surprised. So, you know, about the constraints that I mentioned here, right, and the absence of all these so-called system two things, as we call them in psychology, that are really, I would say, necessary ingredient of a really intelligent system. I don't want to undermine what has happened. I mean, this is all revolutionary. This is all really revolutionary. When you take a look at what can you do with pure associative machinery, which is more powerful than the individual human machine. Take a look at how these machines are programming computers. I mean, they're so super useful coding assistants, right? So it's really, you know, it's opening a kind of human-computer interaction, bringing value into the game that we couldn't have dreamed about that before. So it's all brilliant, but it's still not that real dream that we were dreaming in cognitive science. One day it will be. When? It's difficult to say.
Yeah, I asked you that because I suppose that like most of people that watched that happening, even those that were in the field and covering,
everyone was completely caught by surprise.
Caught by surprise, yeah.
Everyone was completely caught by surprise.
By analog, could we maybe suppose that something like that could happen even in the future, like in the next
Don't
few
get
years?
caught into what neural networks can get caught, and that is to jump to generalizations from empirical observations only. You are overfitting. The thing that it was good yesterday and the day before does not necessarily mean that it will happen tomorrow, right? So yes, now we witnessed a really accelerated technological development, but that happened many times in the past. It stops at some point, and then you have to wait for a new breakthrough, right? But we really, this time I would be, so to say, I don't know, I wouldn't dare to make predictions, you know? I don't think it will happen yet, but ask me next year, then we can talk.
Next question.
Fantastic talk. Thank you so much.
Thank you. Thank you very much.
I myself am AGI skeptic. I think it's very far away, even if it happens at all. My question to you is, what's so difficult and why is it needed to, for example, merge the two approaches to LLMs?
You know,
You
people,
said, I guess it's the transformer architecture and
Whatever.
symbolic AI.
the
Thank
thing
you.
is, well, you know, people were contemplating on such integrations for decades already, right? So hybrid models and ideas on how to build hybrid models are not new. Gary Marcus himself speculated on the architecture of such systems in his book, The Algebraic Mind. That was, I think, 20 years ago or so, not only him. Some of working models were actually presented, but they were used in academic experimental proposals in psychology to fit some empirical data. The famous Lisa system, that was all. Now you have the whole field of neuro-symbolic programming, where people are actually trying to integrate associative learning from neural networks with symbolical approaches. The difficulty is the interface, because here you have a distributed representation of information, while here you have explicit representations, right? Okay. We know that the human brain is doing it somehow, but we don't understand fully how is that done. So first, how to put it, you know, to give it, to find the metaphor in the world of software engineering, you have two completely different, but on the level of philosophy upon which they are based, two completely different levels of representations, two completely different data models. You need to find a way to combine them. That's one thing. The other thing is, we figured out ways how to make processing in deep learning and neural networks efficiently on tons of data, okay? And after that, it still costs millions of dollars to train a huge model, right? With symbolic processing, it might turn out that actually computational computing is even more costly, right? And not only that, it's very difficult to make it very effective upon that scale. So there are several stumbling blocks, okay? And also with neural networks, the principle of associative learning, now empowered with transformers, convolutions, and all these other tricks, which are beautiful. In symbolic AI, we are still not certain of what type of representation of knowledge would work the best, okay? So it's promise, but the implementation is quite tricky, to put it that way. So there are unsolved problems in the symbolic paradigm, that's one thing, and then there is the unsolved problem of the interface, how to put them together.
Okay.
Nature can put it together somehow.
Why do you think there's slow progress in symbolic AI?
It is not in the focus anymore, you know? It's not in the focus. It was always in the history of cognitive sciences. There was this whole pendulum walking from associative approaches back to symbolic approaches. And what is very interesting is that at the majority of the history of cognitive science since the late 50s and the instantiation of the idea that we could build something like an AI, actually symbolic AI was, they were the front runner, to put it that way. So all the hopes was with them. Back in the 60s, even in the 70s, people thought that, you know, neural networks are so constrained that they will never be able to produce useful behavior that will look like as it is intelligence, right? So only the revolution in 2000 actually showed that that is possible, right? So there are people working on that, of course, in fundamental research, but now it's an attention shift. Everyone is looking, back in the 50s and the 60s, everyone was looking at Lisp, at formal processing, Chomsky's theory of transformational generative grammar, and how to implement such things in automatic translation. Now the attention is shifted towards GPT, transformers architecture, similar things, because they translate languages like this, okay? So it's simply a matter of a history of science and engineering. Sometimes one approach dominates, sometimes the other.
Do you think it is
Sorry, but
the two approaches?
The nature has somehow managed to do it. And there is one danger, and that is that we really do not understand that on the fundamental level in the following sense, that our description of intelligence, by viewing these two perspectives, one that we call symbolic, the other one that we call associative, is fundamentally not correct. That is something that we will change in the future and figure out new ways to conceptualize intelligence, but we don't know that. If we talk about these two things as symbolic AI and as associative AI, based on associative learning, nature can merge it. That is our natural cognitive system. So if nature can do it, probably we can do it. We'll see. I hope for
Question
the
on
best.
the-
You're welcome.
Yeah.
Sorry, question on this side.
Well,
Please.
comments and questions. Goran, great as always. And I would just pitch in on Sergeant's comment that he is skeptic. I would say that he is only experienced optimist, so he becomes a skeptic. Two different things to pick your brain. For last year or something, we are hearing about new mathematical advances in low data theory for training networks, like in this case for generative AIs, with low volumes of the data, which will be able to essentially generate more knowledge rather than using like currently huge volumes. I know that for the huge volumes of the data, even Ben, who was here, well, he is now called differently, Gibson, from the Dataiku. He started to make fun on LinkedIn, etc., about Falcon of his biggest LLM model of 576 billion of parameters, because it's the same concept that more data will not bring essentially more knowledge. Well, it will bring some knowledge, but it will not bring reasoning inside of it. So that would be one element. And the other, did you heard about Q-star?
Sorry, about?
Q-star.
Not really.
So there is a theory that everything which is now happening in OpenAI is the due Q-star advances. It's a completely different approach in modeling neural networks in generative AI, and that some of them got frightened that it will skip to the first level of AGI in 2023. So now.
2023.
Yeah.
They have a month. Okay.
Yeah.
So wait,
well,
beautiful.
The first breakthrough,
the first breakthrough,
yeah, the first breakthrough happened like 10 days before last Friday and all the happening.
I will be delighted to see something like that, you know. But you know, my 5 cents is not really happening. And when they publish, let's test. I know tricks, even for the best of their models. Give me 5 minutes, I'll show you exactly, systematically, where the mistakes are and why.
I would say
we will do the same thing with the new thing.
No, I would just say one comment that people at the moment is still, they are not able to define what AGI is. Because even if you ask the Google, they have like 5 different levels of AGIs, and even current Google Translate falls in some of them. So, yeah, I think that we'll need first to focus on definition before we can say, are we going that direction?
We can focus on definitions, but there are empirical ways to test this, you know. As I told you, we will have counterexamples, right? If he can solve these kinds of things, I'm fine with it. We will call it intelligent, but I'm not sure. My point in all these discussions, everyone who hopes that real intelligence will really be some emergent property of a hyper-complicated nonlinear dynamical system represented by a network is not right. Simply laws of associative learning cannot evolve the equations of the formal model that you need for that. I still think that's a valid statement. If anyone proves me wrong, he will be a billionaire.
Not even approximately close.
Approximately close, probably, yes.
Well, that can be good enough.
We'll see how approximately close they get.
Okay. Okay. Another question.
Thank you. Great talk. I actually have a question regarding the risk of usage of LLMs in the business. So do you think that there is a risk that companies will actually now have lower quality products due to the usage of LLMs in their products, rather than using some traditional solutions that are maybe harder to implement, but would have like higher quality?
That is an obviously present risk with the introduction of these things, you know, and that's what to provide an answer to is the same answer that I provide to anyone who recently asked me. It was typically media professional. It's like, what would you do with these things? What can we really do with these things? You know, do whatever you like with them. Avoid doing one thing, not try to make a final product or service by using what generative AIs give you. Okay, so, you know, probably the best thing to do, the most useful use case is helping you in your professional life, anyone's business, you know, making you more efficient, you know, enabling people to put more time into different things that are really difficult and should not be handled by AI, like management, creativity, and things like that, right? So whoever, I mean, I would always suggest avoid basing your final product on the outputs of AI. Use that to help your workforce. Don't use that to sell a service directly. That's how I think that risk can be mitigated. Please.
Thank you. Enlightening talk, really. I enjoyed a lot. This might be a little bit off topic regarding your talk, but I would really like to hear your opinion from your perspective of emergent properties that has happened in large language models.
Emergent properties happen in any neural network. You don't have to build a large neural network to observe emergent properties. The solution of the exclusive OR model that happens when you add one single hidden neuron in the layer is an emergent property of the network, because we never encoded explicitly anywhere the logical function which is called exclusive OR or XOR, right? So the first example when you start learning about neural networks is that why do you need a hidden layer? Because you can solve 4 things that have these crazy exceptions, right? And when you start coding higher and higher order interactions in backprops and things like that. So, you know, my take on emergent properties is there's no magic. The larger the networks get, the more interesting and complicated emergent properties we will start to observe, right? So I understand the surprises that caught many people in the previous 1 year on what these things can do, but they were not explicitly programmed to do. But I really have to tell you, since the 80s and the reinvention or rediscovery of the backpropagation algorithm, that is what people that develop neural networks will tell you, what these things do. These things provide by emergent properties, meaning we do not explicitly program them. That's the essence of the whole approach.
Thank you.
You're welcome.
Okay, here.
Thanks for the talk. It was very good. I like it a lot. So the question is pretty simple. If you would choose like 3 industries or 3 professions for which you would like to build custom solutions based on LLM, what would you choose? What's the, you know, the industries?
3 solutions. Sorry, if I got it
Three
right.
professions.
3
3
professions.
professions or 3 industries which you think are the most ready and will benefit the most from the solution based on LLM or AI?
Anyone who needs to write tons of text in their work, underwriters, media professionals, journalists, all legal applications, typically where you have to write template-like things and then just customize for different clients, things like that. So essentially, I think that writing assistants, that will be a good story. And I know that many are working on that. That's one thing. Then...
Translators?
Translators, definitely. Thank you. That would be the second one. Zoran, do you have the third one? Also, you know, software engineering, look at what we can do with copilots and things like that. So I would say this, wherever this verbal/symbolic reproduction and production, generation of things is needed on a large scale in someone's professional life, these things can really help by speeding you up, making your life easier, helping you.
Thank you.
You're welcome.
Sorry, who was next? There. Yes.
Thank you. I have a short question. Firstly, thank you for a great presentation. It was amazing. Would you say that like we are reaching the limit of our deterministic machines? Would you say that quantum computing, if we develop it enough in next few 5 or 10 years, that we'll have the great opportunity to have an AGI eventually?
Look, I'm not into quantum computing. I only have friends and colleagues who are, right? So I would avoid answering the question directly. I simply don't follow the developments there, except on the level of, you know, everyday news and things that I get from these tech outlets and similar. So I'm not sure what to say about that. I mean, I understand that it would be a huge jump, right? What would it do for the AGI? I'm not sure. But I think if it's still only a training of associative machinery, well, it's going to be a larger language model, right? We can then call them larger language models, quantum language models, I don't know. As of the first question, if we are reaching the limits with the deterministic machineries that we have, look, depends on what we do with them. I think it's been already 5 or 6 years since I heard that prediction that, how to put it, maybe an attitude, from Google's researchers who were predicting that the deep learning paradigm will be able to push for 9 or 10 years since then, at that point. You know what, I mean, it's very expensive, it's very huge. At some point, you know, the moment that we are all waiting for to see, which we cannot know when it will happen in future, is that, you know, when the global validation curve in training starts doing that, then it's finished, right? And when will that happen? How close we are to that point? I'm not sure, because, you know, there are creative people who every now and then figure out new tricks how to do it. Look, it's been this year when the large language models revolution, I mean, it happened before, of course, but the explosion in public and everything. This very year, you know, smart kids figured out quantization methods, right? And said, okay, well, look, I mean, we don't have too many losses here. We can do it and train almost on a custom hardware, almost on a custom hardware. So it turns out that we always find out tricks how to prolong that situation. But sooner or later, yes, we will hit the wall. Don't ask me about the year. I really don't know.
Thank you very much.
You're welcome.
Okay. Well, we have just one question now because we have to finish. Okay, here's.
Dr. Milovanovic, for your very good presentation. I just have one question about the work. The first part of the presentation, I think it's a bit related to Kahneman's work, right? The system one, system two thinking. So I wanted to ask you this transition from that, let's say, decision psychology thing to LLM. Is it your original work? Did you make this merging process, how to approach, or is it something that you combined?
That is related to Kahneman's work, of course, but I just have to tell you, these dissociations between different systems of reasoning, we know about them in psychology decades before Tversky and Kahneman even started their research program in the 1970s, but the system one, system two terminology is something which is popularized after following the famous TK Tversky-Kahneman research program, right? That's one thing. The other part of the question, I'm not sure if I did get right. It had to do with the question if something here is my original research or not.
Yes,
so
yes.
In this presentation, absolutely not. This is my thinking and my reflection about what happened this year.
Yes, that's what I'm asking. Did you make the original thing from transition from those beginning and then moving on to LLM and all those recent stuff? Okay, great. Thank you very much.
Yeah.
Thank you.
Yeah.
Thank you, Goran. And I'm awarding you a certificate for speaking on DSC. Thank you, everybody. That's it for the day on this stage, and see you tomorrow morning at 9:15. We're continuing in the final day.